Let us write a function for converting infix expression to postfix expression. Function name I have given it as convert. It will take a character type pointer to an array of characters and its name is infix. So that example already I have given here. This is an array of size 10 having that same expression, and it is a string, so it is ending by null character, that is /0. So it's a string. So this is also a string or character pointer. It will convert and returns a character pointer. So that's postfix it will return. For this procedure, I need two more functions. One function is operand. This function is to check whether a symbol is operand or not. If it is operand, we want result to be true, that is 1. So here I am checking the condition. If it is plus, minus, multiply, divide, then it is an operator. It's not an operand. So I am returning 0. Otherwise, it's an operand. So returning 1. The next, we need the precedences also. So if you remember the precedences, plus minus is having 1 and multiplication division is having precedence 2. So I have a function for precedences. For plus minus, return 1. For multiplication and division, return 2. For any other thing, return 0. Any other thing means if the stack is empty, nothing is there, then we should have the precedence 0. So that also I have written. So these two functions I'll be using them. So the code will be very simple and easy to read. Now let us come back to the function. Inside the function, I need few things. First of all, I need a stack. Which type? Character type stack. So in parenthesis matching example, if you watch that video, there I have used a character type stack and also I have initialized it. So same thing we should do here. I will not explain that. I will directly declare a stack. So a structure type stack, that is st. st is a stack and that will be holding characters. So it's a character type stack. And also I will initialize it. So I will write a comment here that it is initialized. So assume that it is also initialized. It knew few statements that you have to set the size of a stack and create an array and initialize top pointer to -1. So 3 statements you require. I'm avoiding that. So you can check it in parenthesis matching. The next thing what I need is I need a postfix array to store the result of postfix. So what should be the size of this one? Same as infix size. So I will create an array equal to the size of infix. Here I have taken character type pointer, that is postfix, and also creating a new array from heap, and size of that array is equal to string length. And as this is a string, we need one more space for null character /0. So that's why +1. Then I need few variables for scanning through this infix expression and scanning through this postfix expression. So I need 2 integer variables that are I and j. So I have taken I and j, both are initialized to 0. Now the procedure. In the procedure, I have to scan through complete infix expression from first symbol till we reach the null character. So we have to go on scanning all of them. So shall I use? So I can use a for loop. So for loop will be taking me through all those symbols. But instead of for loop, I'll prefer using while loop. Reason I will tell you afterwards. I will not use for loop, I'll use while loop. So how long that loop should execute? Till we reach the null character. While infix of I is not equal to null. Until you reach null, continue. Then what I have to do every time? So if you remember the procedure, we were checking every symbol whether it is an operand or operator. So if it is an operand, we were adding it to postfix. So that code I will write down. See, to check whether that symbol of infix expression, let us say first symbol, is it an operand? I'm sending it to this function. So this function returns true if it is an operand. And if it is an operand, then directly I should send it to postfix. So the symbol of infix expression should be stored in postfix and index I and j both should be incremented. So copying that symbol here. If it is an operand. If it is not an operand, then it is an operator. Then I have to check the precedences. So else, I will write on that part. Else, if it is an operator, then I have to check the precedence of a symbol from infix expression and the precedence of a symbol in the topmost position of the stack. That's what we were doing. So I will write on that one. And If the precedence of infix expression is greater, then push it into the stack. Otherwise, pop out. I will write down that code. Now, here I will read it out. If precedence PRE, this is precedence function, of infix symbol of I, infix of I. So I may be here or here, wherever. I may be on this operator or this anywhere. It's on the operator. So the precedence of that operator is greater than PRE, precedence of stack top. Stack top function, we already know it gives the topmost symbol in the stack, and we know stack is containing only operators. So check their precedences. If the precedence of this symbol, that is from the infix, is greater, we know we will push it into the stack. Push it into stack st, that infix of I, and also move to next symbol in infix. So if you have pushed this one, go to next symbol, plus plus, I plus plus. If it is not greater, if this is smaller than that one or equal, then pop out a symbol. Pop out a symbol from the stack and add it to postfix. Generate a postfix array. So you remember we were generating postfix. So generate that array. And in infix, remain on the same symbol only. Don't move. I++ was done because it was pushed into the stack. But here I++ is not done in else part. So that I will not move always. It will not move always. That's why I have not used for loop. For loop means every time it will move to next I. While I am using an I am moving it. If it is an operand, goes to postfix. Move to next symbol. Means if it is A, move to next. Then, if the symbol is pushed into the stack, then move to next. Otherwise, don't move. Because you are popping out a symbol from the stack and add into postfix. Don't move. Be on the same symbol and continue again and check again with the stack top. That's all. This is the procedure. Now the part that is remaining is whatever was remaining inside the stack, we have to copy that in postfix. So that portion, there is no space. So I will remove this function and I will show it here. So here I will write on the code for copying all the contents from the stack. So pop out the values from the stack and go on adding them to postfix until the stack is empty. While not is empty. St, stack. As long as the stack is not empty means when it is empty, stop. If it is not empty, continue. What to do? So inside postfix expression, pop out the element from the stack and add it to postfix. So stack will be containing operators. Those are popped out and added to postfix. So this loop will copy all of them. Then after copying all, I should add a null character at the end of postfix because postfix is also a string. String means it must be terminated by null character. So add a null character. That's all. We got the result. Return that postfix. That's all. So finally, postfix is returned and end of the function. So this function will convert infix to postfix. That's all. This is the program. I will write and run the program and show you.